All right, here we go. Unit 5, Lesson 2. It's one of my favorite lessons. It involves Play-Doh and these giant playing cards. Hey, that's a symbol in sacred geometry. Anyway, getting really big into sacred geometry. Can't wait to show you the Niners logo we did. But anyway, here's Unit 5, Lesson 2. So let's analyze cross-sections by slicing three-dimensional solids. So what you need to do here is, well, you either need some Play-Doh or you need to like visualize and imagine the Play-Doh molds that I'm gonna build. But 2.1, slice this. It says, imagine slicing a cylinder with a straight cut. The flat surface you sliced along is called a cross-section. Try to sketch all the possible kinds of cross-sections of a cylinder. I'm going to give you an example of a few shapes coming up, but here's a cylinder. I got this as a gift from a fellow teacher, DMX. Y'all gonna make me lose my mind. Up in here, up in here. Anyways, this is a good example of a cylinder, this coffee mug. So imagine I do a horizontal cut, and then you like look inside at the shape, you're gonna see a circle. So that's the cylinder one. Now imagine if I cut this coffee mug in half, what shape do you think you would see on the inside? It's actually a rectangle. And then what if you did like a diagonal cut? Like, so I cut from like the top to the bottom. You would see an oval, believe it or not. So anyways, we are going to run this real quick with Play-Doh. So that way you have like a visual aid on this. So I'm building it right now. Easiest way to build Play-Doh cylinders is to roll it a few times, like so. I'm just like getting it going, rolling it. And then you like smash it down on both sides, starts to create circles. And I'm just gonna do it over here where I have a harder surface than a workbook. All right, smash them down. Getting there, it's almost built. Sometimes these Play-Dohs are a little broken apart, that's okay. Play-Doh is great because it allows you to mold the Play-Doh into different shapes. Alright, here we go, we're almost there. Build these circles on the bottom and the top. I'm trying to create a beautiful mold so I can demo what we're about to witness. Alright. I just want to let you know on these, like some of these are tricky, and it's okay to not know the answers, but we're going to try our best. That's all you can do in anything in life. Okay, so you've got this, we'll just call this a cylinder. Jeez, I'm not digging this Play-Doh. I'm gonna get a new one, actually. This Play-Doh is not up to standard. Be right back. I've had these Play-Dohs for like 3 years. I've got a little wear and tear on them. With Play-Doh, some people will leave them out, not knowing that they end up like hardening, and that's my bad, because I gotta be on top of those things, see those mistakes coming before they happen. But anyways, I'm building another cylinder with this Play-Doh. It's not perfect, but it's pretty good system for demoing cross sections. That's the big word you need to know for this lesson. Gosh, these are both pretty bad. Eesh. Just wondering what the students are thinking. All right, 2 in a row that are awful. I'm gonna be back again. All right, I hope 3rd time's the charm. Here we go. Play-Doh's not perfect again, but hopefully this will work. I'm just trying to get it all together in one big irregular shape. That actually comes up later in this unit. Calculating the areas of irregular blobs, which is kind of cool. You can actually create formulas for area and volume. All right. Oh man. Of course I chose brown. Oh man. This could be funny. I shouldn't laugh so hard on video by myself. Jeez. Alright, here we go. We've got a cylinder forming. It's pretty good, yeah. Oh man, I'm so immature sometimes. Alright, here we go. Here we go. We have to do a second take of this video. Alright. Okay, so we got a cylinder, yeah? If you know what I'm laughing at, you realize I have the maturity of a 6-year-old. Alright, here we go. Trying to get circular bases, because that's what a cylinder looks like. So, here we go. Alright, imagine slicing a cylinder with a straight cut. The flat surface you sliced along is called a cross section. Okay? Try to sketch all the possible cross sections of a cylinder. So, we've got a cylinder. Here's how I draw cylinders. Start with, well, it's an upright cylinder because it's straight up. It's not tilted or slanted or oblique, as you're gonna learn coming up. This is a right cylinder. All right, so first cut. We got this large playing card, which I like to use. We're gonna go straight through horizontally. So we'll do a horizontal cut of my cylindrical Play-Doh poop. Okay, here we go. Right through the middle. We're just cutting this cylinder through the middle. The cross section for a cylindrical poop looking Play-Doh is a circle. Meaning, if you cut this cylinder in half, you're gonna see a cross section here. That is a circle. All right, let's do the second one. This time it's gonna be a vertical cut. Okay, so we're going through this way. All right, so I'll just use one of my cylinders that I already had built. I'm gonna use this one. So we're gonna go through this down the middle. You gotta be kind of gentle so you don't mess up your Play-Doh. giant playing cards work well for this lesson because it represents a plane very well. So imagine the cross section is the intersection, all the intersections of the Play-Doh and the playing card. So that's going to be the inside shape that you see. So I cut it right down the middle. When you look at it, you should see a rectangle. Remember that a square is also, or a rectangle can be considered a square also. So if you had a taller cylinder, this would clearly be a rectangle, right? So anyways, cross section is the intersection of the playing card, right, with the Play-Doh. Boom. Right? It's a plane going through a solid, cutting through a solid, and they intersect at a rectangle. So, vertical slice ends up being a rectangle. Pretty cool. All right, let's look at the last one. Last one, I get to draw one more cylinder. This one we're going to do a plane. You can envision a playing card, really. I'm using the ace of clubs, so let's just name it the ace of clubs. Okay, so our ace is cutting through this cylinder, and it's going to form a cool intersection. So here we go. Let's see if I can do this one more time real quick without costing us too much time. Should have had 3 of these ready to go. Oh well, lessons learned. Building my Play-Doh molds. Wonder why brown is the least popular choice for Play-Doh. Oh. All right, here we go. We're going to do a diagonal cut. All right, and then we're just going to open it up and analyze it. It's actually an oval. So believe it or not, the diagonal cut is an oval. Pretty cool. All right, next up, we are going to do a table. So we're going to do 3D shape. We're going to do horizontal, vertical, and diagonal for all of these. Okay, so we're gonna do a couple of different shapes. First one. Well, let's do cylinder. Just recap what we learned above. Horizontal was a circle. Vertical was a rectangle. And diagonal was an oval. Okay. Second one we're gonna do is super easy. We're gonna do a sphere. All right, so there's basically a sphere. Just gotta roll it a few times in your hands. And then we're gonna do some cuts here. So a sphere. I'm gonna draw just a little symbol over here. There's the cylinder, the sphere. Might even want to draw a basketball real quick. Okay, so we got a sphere. Let's chop this one in half vertically. So here's my vertical cut. And we're just gonna take a look at what we see. Now, wasn't the greatest sphere in the world, but what you should see on the inside is a circle for all. So no matter which way you cut a sphere, you're gonna have circle cross sections. Now remember, cross section is the intersection between playing card and the Play-Doh, or the intersection between a plane and a solid. So they all intersect wherever the plane and the solid meet. Okay, next one, cone. So the cones are tricky to build, but that's okay. I'm gonna use this little circle on the bottom to help us. But first I gotta get an apex, because a cone has an apex. What is an apex? Well, it's the top. So this is the first one that has an apex. So the cone right up here is the apex. So I'm just building an apex, basically. Trying to get it formed so it's clear. Now we're gonna try to make a circle down here. Okay. So we got a cone here, right? Now we got to do the horizontal cut. So the horizontal cut is like this playing card through the middle of this cone. So here we go. Okay. In both sections, circle. Okay, cool. So the horizontal cut will create a circle. Wonder what the vertical cut will create. Create an apex. Be a circular base. That's what cone is. Circle, cone. Now we're gonna do a vertical cut through the apex. Remember, the apex is the top. Now if you need to remember what an apex is, think about an apex predator. Now I surf on occasion, not very well, but I try to get out there as much as I can. And an apex predator that's in the ocean is at the top of the food chain. No surprise, the apex is at the top of the cone. Apex predator, shark. Cross section, vertical, triangle. Now, I'm already realizing I didn't follow the instructions because they told me to sketch. So, we're gonna have to do that at the end. All right, one more cone. Yeah, apex, again, apex is the top of the cone. All right, here we go. Circular base, apex at the top. Let's do a diagonal cut. You're gonna see again, not the greatest representation, but if you did a cone perfectly, you're gonna see a oval again. Interesting. Last but not least, we're gonna try let's just do the cube. That'll be easier. For this, I'm gonna use, for the interest of time, I'm gonna use this Rubik's Cube. Zoom out a little bit. All right, so you got a Rubik's Cube, right? We all know what that is. Imagine I cut this thing down one of these slits here. You're gonna get, so I'm cutting this thing straight through. I gotta zoom out even further, jeez. Okay, so imagine I cut this Rubik's Cube down this, using the ace of clubs again. So I'm cutting the Rubik's Cube, and then say you opened it, you would see a square for a vertical cut. Now, what if I did a horizontal cut? So over here, I'm cutting it this way. You can already imagine what that would be. That would be a square as well. And now let's do a diagonal cut. Well, I don't exactly know yet. Let's say I cut this thing down with a diagonal cut, or actually let me do it like I have been doing. Diagonal cut, you're gonna have a side, so I'm gonna use this face. You're gonna have a side like this length, right? And then you're gonna have a side this length. This is longer than this because of a squared plus b squared equals c squared. So because this is a tiny bit bigger than this side, a diagonal cut of this Rubik's Cube is going to result in a diagonal cut of this Rubik's Cube. Just trying to envision it for a diagonal, a diagonal cut this way is going to lead to a, can you imagine it? That's the two-dimensional shape you're gonna see. If I cut this thing like this, it's gonna be a rectangle. So we got square, square, rectangle. Now, if you want to keep going, you could do a pyramid. You could do a triangular prism. You could do any shape and just use like a playing card or a giant playing card. Just cut through them and observe the shapes that you make. Okay, cool. 2.3, now we're done. I'm gonna skip number 2. It's confusing. Now, each question shows several parallel cross-sectional slabs of the same three-dimensional solid. You need to name each solid. So I see these as like stacked on top of one another. So each one just a little bit smaller than the big one. So there's like 1, 2, 3, 4, 5, 6, 7. So there's a stack of 8 of these triangles. And then just imagine it gets all the way to the top. And this is a face. This is a face. This is a face. This is a face. And then the bottom is a triangle. That would be a triangular pyramid. Right? Now, let's look at this one. Now imagine this little mini basketball. If I cut it like along this line, somebody had taped it together and then we took off the tape for some reason. And then you opened up the basketball, like the middle would be bigger, like represented by this one. And then if we cut it like on the side, right, parallel cross sections. So this line's parallel to this. And we opened it up, it'd be a little bit smaller. And then we cut one like right here, be a little bit smaller, so on and so forth, until you get to the very top that you do the like final cut, which would be like this one. You're gonna get a sphere. It's a pretty flat one. I'm gonna pump it up a little bit. So this one's a sphere. Now, the book tells me that this is a cube. A cube, not ice cube, but a cube. Like the Rubik's Cube. Anyways, that was Unit 5, Lesson 2. Let's talk about the things you need to know. Lesson 2 summary. In earlier grades, you learned some vocabulary terms about solid geometry. A sphere is the set of points in three-dimensional space, the same distance from the center. A prism has 2 congruent faces or sides called bases. The bases are connected by parallelograms. A cylinder is like a prism, except the bases are circles. A pyramid has 1 base. The remaining faces are triangles that all meet at a single vertex. A cone is like a pyramid, except the base is a circle. We often analyze cross-sections of solids. So these in blue are cross-sections of solids. A cross-section is the intersection of a solid with a plane. So playing card with Play-Doh, right? Playing card with Play-Doh, playing card with Play-Doh, playing card with Play-Doh. So cross-section is the intersection of a solid with a plane or a two-dimensional figure that extends forever in all directions. For example, some cheese is sold in cylindrical blocks. For example, if you stand the cheese on end and slice vertically, you'll get a rectangle. So that's that one, rectangle, boom. That's a cross-section of the cylinder. Here are 3 more examples of cross-sections created by intersecting a plane and a cylinder. If you want to serve your cylindrical cheese at a party, you might cut it into several pieces like this. 1, 2, 3, 4, 5, 6, 7. The pieces are thin cylinders. They are like cross-sections, but they are three-dimensional. all the cuts were made parallel to one another. By looking at the slices or by stacking them up, you could figure out that the original shape of the cheese was a cylinder. That's pretty cool. Now the two-dimensional shape you see is a circle. We covered that, kind of like that. The diagonal cut turned into an oval. Now this is the diagonal cut that goes through the top, so it's like a semi-oval. So, glossary terms: cone, cross-section, cylinder, face, prism, pyramid, sphere. I think we use those all in this video. Come see me if you have more questions. And remember, if you don't do the practice problems, you're wasting your time in class, because what will happen is you'll learn a little bit in class, but until you actually do these practice problems, like, the concepts don't actually stick. So, just do the practice problems. That way you don't waste the 100 minutes that you're in class. All right. Oh yeah, one last thing. Go Niners. Here we go. My Unit 5 board is done. Let me zoom out a little bit. So here we go. San Francisco in the Super Bowl. It's on Sunday, February 11th. There's the sacred geometry corner. I got a Trinity knot, yin yang, seed of life, and of course the Niners logo. And that sun could be considered a burst, which are all out of this book right here. So I want to give props to this author real quick. Ana Victoria Calderon, thank you. Such a cool book. Anyway, have a good day. Bye.